So basically, today's agenda is basically learn how to develop Spark application using AWS Glue. Okay, so AWS Glue is basically Spark as a service. Okay, you have heard multiple clouds like software as a service, infrastructure as a service, function as a service. Similarly, Spark is also another default choice for developing big data applications these days. So that's why many different companies or cloud providers, they are providing Spark as a service also. Okay, you can basically, so you understand like what is as a service. For example, I'll give you a quick example. Like earlier, you remember 5 years back, people were using Microsoft Office. Like you have to install Microsoft Office on your system. You have to add the license key and then start using it. But now you see like many companies, they are preferring Office 365, which is a cloud version of the same. You can access the entire service over cloud. You don't have to install anything on your machine. You don't require that much of infrastructure like hard disk, RAM, and processor to process or basically use Microsoft Office software on your machine. Rather, you can just open a browser tab and you can start accessing Office 365. You're getting all these services like Outlook, Word, Excel, PowerPoint, everything on a web platform, on a browser platform. Right? That means you can say like Microsoft Office as a service. It's so popular, many people are using. So you at the same time you don't have to install this kind of heavyweight process in your system, and you can directly use it from the from your browser itself. Okay, similarly, Spark is also, you saw like you spend a lot of time developing application in your local computer. You install Python, you install like a couple of other services, and then you start doing the development in your local computer, right? And then you basically move it to the S3 bucket, and then move it to your AWS EMR cluster, and then run it. So apart from the business logic implementation, you have a lot of engineering work also involved here. Engineering as in a lot of software installation configurations, and then you have code repository, you have your so we didn't discuss about the CI/CD part. In real-time application, you may find some CI/CD activities also, like continuous integration, continuous deployment using Jenkins, right? Then you basically run this application on your then basically you have to create a cluster manually. You have to spend some time understanding what is the right configuration of the cluster to be used so that you will get maximum optimum result, right? So creating cluster, setting up the executors, and the Spark Summit command, framing Spark Summit command itself is challenging work. So and all this. So to avoid all these hassles, we can think of like using a platform which gives us the interface to write the Spark program directly without thinking much about the engineering stuffs like how to basically maintain the code repository, how to implement the CI/CD pipeline, how to create a cluster, how to automate the cluster creation, how to basically configure the right Spark Summit command. So all these hassles has been removed. So you'll be simply given a text area. You can write your code there and execute it. Okay, so it will automatically create the cluster and execute your job. Okay, exactly same service what you saw Databricks. Databricks is also a Spark as a service. Okay, you also there you are writing Spark application without installing IntelliJ or like this PyCharm, without installing Python. All these things you are avoiding. You are simply focusing on the programming part. Okay, so whatever the business logic is, you are writing the business logic in Spark, and then you are just with few clicks you are able to execute the code. So that's the whole idea of like Spark as a service. Okay, you are basically using Spark as a service means you are avoiding all these DevOps or engineering work. Okay. So for that, like we will be starting using AWS Glue. We'll do two examples. Okay, just to summarize whatever things we saw in the Dataframe examples. So what we saw in Dataframe, we saw data ingestion, data curation, and data provisioning, isn't it? So to summarize all these three, I've created two examples. One is a simple data ingestion problem. You will be reading data from Amazon S3 bucket and you will be writing it to Redshift. Okay, that will be one pipeline. to show the examples of ingestion. And to show the curation part, we will be doing a similar thing. We'll be reading data from S3, that credit transaction amount. Then we will apply some aggregations, the account number wise, find out the sum of transactions. And then the result, you will be writing it to Redshift. That's the end-to-end pipeline. Like that involves data ingestion, data curation, and data provision. Okay, so we'll be trying these two examples, and so that will be sufficient. Then you can take it forward. Like you want to implement any complex pipeline, that also you can do. Okay, so here what we can do. So now what we can do, we can before jumping into AWS Glue, we have to create a IAM role. Okay, so let's first create a IAM role here. My voice is audible, right? Ankun, everybody?
Yes, yes.
Okay, I'm just creating a role. Here you should see there is a glue option is there. So select glue. Next permission. So we'll be reading data from S3. So I'm trying to give S3 full access. Then Redshift. And then Redshift. And then Redshift full access. Then there is a Glue service. AWS Glue service role. Okay. So I'll be giving it a name, say AWS Glue service role. Okay. So then create a role. Okay. So we just created a IAM role. We are giving all these permissions like reading the read write data to S3, read write data to Redshift, and then a Glue service role. Then we have to create a VPC endpoint. Okay. So you can just ignore this configuration. These are purely DevOps part, like IAM role creation and VPC and all this. So I'm also not master in this, but I'm just following the steps like through a couple of examples. But for you, like in the company, the DevOps person will do all these things for us. Okay, so we'll go to endpoints. Create endpoint. Search S3. Okay. Once you select that, then that should be a single VPC only. Then select this route table. Full access. Okay, we created endpoints. Then we should be having security group. Okay, security groups you can see. So we also have to create a security group here. Give the name as self only. This is the default VPC available to you. All traffic. Yeah, just click create. Okay, that is there. And one more thing we have to do, we have to add this security group to our Redshift. Okay, we have created our Redshift cluster earlier. Okay. You can click edit. VM network and security. We have this self is also appearing. Why is it not adding? You can see I have to select control and both the security groups you have to add, and that's it. It didn't ask for any credentials. Is it modified? Let's quickly see. Can anybody see like where the security group is appearing? Network subnet. Yeah, we can see two such security group. Let's just confirm like is it a new security group added or not. Self it ends with CFEFAD. CFEFAD, correct. Okay, now our basically configurations are done. These are the basic configurations required. Okay, so now we can create a pipeline there. Okay, so we can create a pipeline there. So let it be here only. This is the query editor. Okay. And let me quickly send you these two queries. We have to create two tables in Redshift for these two use cases. First one is basically a simple data ingestion pipeline. And the second one is basically all like data ingestion, data curation, and data processing. Okay, so we need these two tables. Yeah, just okay, just leave the control, Oh, where it is creating, and it shouldn't create here, it should create in public schema. Okay, create transaction. Create transaction add. Yeah, these are the two tables. It's available now. Now we can go to Redshift, sorry, Glue. Okay, AWS Glue. Okay, many small companies or startups, they are using Glue extensively. At least in US, I'm seeing there are a lot of opportunities on Glue because of the obvious reason. Because you can imagine like startups who have very less budget or like who are running on fundings only. So they are basically avoiding developing applications from the scratch, setting up a big like team or like data engineering. Rather, they are using Spark as a service so that development is faster here. Okay, a proper hands-on guy in Glue can develop big projects in few days only. That's because there is no other engineering or DevOps part, simply just create the pipelines here. Okay, so it's one of the choice, like many startups are using AWS Glue or Databricks and all. These are costly for sure, but like development is very easy here. So now, so to do the data ingestion, to read or write the data, here you have to create crawlers. Okay, as the name suggests, crawlers. So crawlers are used to, we will be creating crawlers to crawl data from S3 or crawl data to S3 or crawl data from Redshift or to Redshift. Okay, like that. Like you can read, write data using crawlers. Okay, so under crawlers, you can see classifiers. Classifiers is basically the property of the crawlers. Okay, you are reading data from file. So what are the different properties there? Is it like what's the delimiter? What's the is that file is having header or not? So those kind of information is provided here as classifiers. So let's create a classifier quickly. The classifier name is so create transaction CLS. Okay, it's saying what are the different type of files: grok, xml, json, csv. So I'm using csv. And the delimiter for delimiter it is tilde only for us. Quote, we don't have any quote, and has headings. Okay, and we have to pass the let me quickly see the data, how it looks like. Okay, so this is the data. You can see it's the tilde delimited file. So I'm copying this. It's saying you have to pass the headers. So you have to pass it through comma separated column names. Okay, this classifier, you can see it's a very simple classifier. We are saying read any kind of file which is tilde delimited and is having header, and this is the header. Okay, so I'm creating a classifier, and post that I'll go to crawler. I'm saying add a crawler. Okay, it's saying crawler name, create transaction S3. I'm reading data from S3, create transaction S3, and click next. Okay, crawler source type, data source existing catalog or folders. Yeah, it's fine. Next, choose the data source. It's showing S3, JDBC, DynamoDB, and all this. And now we are saying S3 only because we are reading data from S3. Connection, no connection. Include path. So it's saying S3 colon double slash bucket and all this, right? So S3 colon double slash. Let's see what's your bucket name. Okay, this is my this is my S3 path from which I'll be reading data. Add another data source. No. Then choose an IAM role. So send on the one IAM role. Make it the one which we have created now. Then next. So it's saying frequency and what frequency you want to crawl data from that source. I'm saying I don't want to schedule it right now since I'm doing the development. I'm saying run on demand. Every time I click here, it will be running. But in production, we can basically specify the schedule time. Okay, so then it's in database. So I have to create a database here. Database means a schema basically. So I'm saying say create txn s3db. So create txn s3db. Okay. Prefix I'm saying say give all these table names with s3 underscore. It didn't ask me to mention the what you call the classifier. Yeah, we should be able to do that. Click edit. It was there. The crawler, what the classifier, what you have created, that's I'm just adding. Okay, you can, I just missed it, but you can do in this way also, that's not a problem. So while creating then itself, you can mention the classifier or you can modify it also. Okay? You may require in the while doing the development multiple times you have to do the changes and all. Now I'm just saying run crawler. So it will take a while to crawl it. Okay, so basically in the backend, what it is doing, it's reading data from Amazon S3 bucket and it's creating a Athena table and writing the data there. Okay, that's what it will do here now. Similarly, so this will be our source and our destination will be a Redshift. So for that, you have to create again another crawler. Okay, I'm going to crawler again and clicking add crawler. So let it run, it will take some time. It's not that instantaneous. Okay. Create txn Redshift. Okay. Okay, so before that, I think we have to do one thing. Okay, let's see if it gives us the permission. Security configuration nothing. Next, data source existing table. Okay, not S3, rather JDBC we have to make because Redshift is not appearing. So JDBC connection. Okay, you have to add a connection here. Redshift connection. Connection type is Redshift. Now you can see under subsection it's showing AWS Redshift and then RDS, DynamoDB, Amazon Document DB like that. Okay, so I'm using Amazon Redshift. No SSL connection. Cluster. I have one cluster only. Database name is dev. It's automatically picking up. Master. Temp 1 2 3 4 TMP 1 2 3 4. Okay, include path. Okay, so it's asking database schema table. Okay, database schema table. Okay, database schema table. Okay, our database name is I think dev. Schema is public, and table name is create transaction. Okay, connection. You have to select that Redshift connection.
Yes, Siddharth. Yeah, for creating this table create transaction, we use which database? Yeah.
Public database. So if you see here, under public only we have created it. Okay, so you can see, you can refresh it also. It's in create transaction. We have created this table create transaction. It's appearing here under public.
Public schema.
Yeah.
It's a MySQL.
No, it's Redshift. It's Redshift database. Right? We have opened AWS Redshift.
Okay.
So now it's in database. So let's create a separate database here. Create transaction Redshift DB. Redshift underscore next. Finish. Okay, so you can see this one is already finished. Okay. So the earlier what we have just executed, it's finished, and you can see the logs also. So it started the crawler, classification complete, crawler configuration is create table this, finished writing catalog. Okay, it looks like everything went good. Then we have just created this one. For that we have created a connection. Let me quickly see the connection correct or not. Okay, let's see. So we are basically this connection, it's testing it. Let me take a few moments. Okay. Yeah, so you can see Redshift connection is successful. That means we tried to make a connection from Glue to Redshift, so it's working fine. So now we can prove this also. Okay, so this already we have done the testing. Here also you want to test it. Okay. So this is how you can basically create your crawlers and all. Now you can just create a duplicate tab. Here I'll be now creating job. Okay. So basically here you saw like you are creating crawlers, or you can say like in plain English, these are basically It's English term only. Crawler, as the name suggests, it crawls the data from one source to from a source, or you are crawling data to another destination. Both read and write. Okay, crawling data from S3 or crawling data to Redshift or S3, like any source and sink combinations are available. And job is basically you have to orchestrate multiple crawlers together. Okay, you have to keep adding multiple crawlers, and then of course, like once it creates the job, you can there modify the code also. If you want to make some custom tweak, you can do that there also. Okay, so that is also there. So here basically we have created these two crawlers. Okay, so this takes time basically. So here basically let's add a job. Say I'm saying say S3 to Redshift, and role is same AWS Glue role. Type. So what are the type of jobs you can create in Glue? So here you can see it showing you can create a plain batch Spark application. All these Dataframe examples you did, that also you can do. It also supports Spark streaming. Okay, you can develop Spark streaming application also here. And Python shell, you can write normal Python program, standalone Python program also. All are supported here. Okay, so we are selecting Spark. Then it's saying like what you are selecting. Okay, so which version of Spark. So you can see it's saying Spark 2.4, Python 3 with improved job startup time. Okay, so I'm using Spark 2.4.5, so I'm using this one. Okay, Python 3. But you can see like you can do Spark with Scala also. You can see the below on Scala, here also it is Scala. All these things are there also. Okay, so here I'm using Spark 2.4 Python 3 with improved job startup time. That means I'm using PySpark only. So you can provide your own script, or you can ask Glue to create a script for you. Okay, a new script authored by you. Okay, so a proposed script generated by AWS Glue that I have mentioned. Script file name is S3 to Redshift. So now it's basically creating its own directory, but you can use your own also. You can specify your own directory also. I'm just leaving it default. And I'm going to next. Okay, let me see if it is finished or not. Before that, I can't do anything. It's taking time. So you can see like it is now, it's showing like it's finished, and the logs also you can click. And you can see all these log statements. Crawler started, running start crawler, then classification complete, crawler configured with schema, change policy, create table, finished writing to catalog. These all these things are finished. Now we can come here to the AWS Glue console. So now you can see there are two crawlers are appearing. Okay, for us the data source is S3 only. S3 create transaction CSV. Okay, create data source. Okay, if you remember, we have created a source with prefix S3 underscore. So S3 underscore create transaction CSV. Then we are clicking next. Okay, then we are saying change schema and find matching records. Machine learning transformations are currently not supported in Glue. Okay, change schema. Okay, let's see. Choose the target data. Target data is the Redshift only. Then it will showing the mapping. Okay, so account number from the S3 file and account number there. Means I've created exactly mapping table in Redshift. Okay, so it is string to string, double to decimal, string to string, string to string, like that. These are my source S3 columns, and these are my target Redshift columns. So then I'm clicking save job and edit script. Okay, so you can see like it just created the script for us. Okay, so Let me copy it to our notepad. Let's see how the script looks like. You can see a lot of command lines are there. You can skip those. So first it created the Spark context object, then it is creating Glue context object by passing Spark context. Then Spark session also it created Glue context dot Spark session, job init. This you can remove this in comments. A lot of command lines. A lot of command lines been added here. You can just clean it so that you can read the code quickly and understand what it's doing. Only 4-5 lines of code. Okay, so what you can see, first it created the Spark context object, Glue context object. It's an extra wrapper on top of Spark, so that's why they have created their own context object. Then they are creating a job and job.init by providing a job name and arguments. Then you can see data source is Glue context.create dynamic frame. So here in Spark we are learning Dataframe, but here it is called dynamic frame. Okay, they are creating a separate wrapper on top of Spark's Dataframe, and obviously they must have added a couple of other functions also. So Glue context. So we were creating Spark context, Spark session.create data frame. So here it is Glue context.create dynamic frame. From catalog, you are saying create transaction S3DB, table name is S3, this one. Okay, so it creates tables in Athena. Okay, this catalog is nothing but Athena catalog. And transform context is data source. Okay, the same data source name what you have given, you're giving the same name. Then you are saying apply mapping. Then you have to map, not source to target mapping, rather the column name mapping, it happens here. Account number string, account number. So we didn't do any change, so that's why it's saying the mappings are same, amount. Then date, category. Okay, transform context equal to apply mapping one, same variable name. Then select fields. Okay, which fields you are selecting from this particular data frame. Not necessarily you are using all these columns. You can basically select on the required columns for your application. So here you are selecting fields. Okay, apply mapping, frame equal to apply mapping, path equal to all these columns it mentioned. Okay, it didn't filter out or restrict anything because we are reading all 4 columns from S3 and writing all these 4 columns to Redshift. So are selecting all 4 columns, and then resolve choice policy dot apply. Then select fields to choice match catalog. Database name is create transaction Redshift database. Table name is this. What we have given. So table name is we have given dev/public/create transaction. So it's also giving the name accordingly. You can say Redshift underscore dev underscore this, like that. Then resolve choice. Okay, resolve choice is what? It's applying this resolve choice. This is redundant. And then Glue context.write dynamic frame. Okay, so basically what it is doing, it's basically now writing this data to. So just like we write dataframe.write.mode .csv parquet, like that what we mentioned. So here it is having its own syntax. Glue context.write dataframe from catalog. So one thing is basically confusing here is basically we can see we need to learn all these APIs of data dynamic frame and all. Yes, you can learn so to become to make use of AWS Glue efficiently. But at the same time, if you want not to use dynamic frames API, rather you are more interested in Spark's data frame, still you have an option. You can convert this dynamic frame to data frame also. Okay. So just like here, you have created this dynamic frame, you can convert that to data frame also by calling .2df, and then you apply your logic using Spark's data frame. And of course, like you should be also converting a Spark data frame back to dynamic frame by calling glue context dot create data frame. So you create dynamic frame, and you can pass the Spark context as well as glue context as well as the Spark's data frame. So that means backend flow conversion between Spark's data frame as well as Glue's dynamic frame is possible here. Okay, that is there. So this is the job it's going to. So I just keep it for my reference, but I'm not modifying it here, and I'm simply calling the run job. Okay, it will also take a lot of time. Okay, let's give it. So you can see job is completed, and how to validate. Obviously, I'll go to my Redshift section. Okay, let's see how the table looks like. So basically, it's simply an ingestion problem. We read data from S3 and write it to Redshift. Okay, so you can see the write is completed. Okay, the data has been written there to this particular table. Okay, so that is there, and now we'll see a little. Anybody having any queries till now? What we have just, I know like the APIs are different, but yeah, like any queries in this?
No, Siddharth, but here if you want to apply our custom logic, we can modify here, right? In the script part.
Definitely, we will be able to modify it. We'll see that also.
Okay.
Any other queries, Kishore? Okay, so now we saw one data ingestion problem. Next, what we'll be doing, we'll see like how to do an end-to-end pipeline. Means read data from some system, apply some data curation, and then write it to Redshift. Okay, so now we'll be writing data to another Redshift table. So that means I have to create again another, because this Redshift crawler is for create transaction table. For create transaction ag, create txm ag Redshift. Okay, so then no classifier. Then next, then we are selecting JDBC. Select connection, the same connection we can reuse. Path. Okay. Dev slash only things we have to change it here is basically the table name is create transaction ag, right? Create transaction ag. It's completely a new crawler. For every other source and sync, we have to create crawlers. So that's exactly what we are doing here. Next, run on demand. Okay. So let me create a new database again. Create transaction ag Redshift database, and then you fixes I'm saying rs underscore Redshift underscore. It's a user defined name I'm giving. Then next, then finish. Okay, so now let's test it. Okay, so this is there. So it will take a while. Meanwhile, let's create a Glue job. So now what we'll be doing, let's close this. I'm giving the S3 to Redshift ag. Okay, so I'm doing some aggregations and writing it to a different table. So I'm using the same. Okay, so here there is a catch actually. What I'll be doing, I'll be following the same approach what I did last time. Only after that I will just tweak the code. Okay, and just click next. Source is S3. S3 create. Okay, we have to wait. I think we have to wait till completion. So you can see it's just created and now it's stopping. Okay, then you have to create the logs. Then we can verify it. So you can see it just created the logs also. You can just check like whether things are fine or not. Color configured, create table, finished writing catalog. Okay, so everything went fine. Now we can create a job. So again, now three things are appearing, but still I'll be using the source as the same source. Target also same. Previous I'm not using ag because I don't know actually how to change the mapping here, but programmatically we can change it. Now we'll go to the code here. I'll take out this particular code. Okay, so let me quickly clean this. Okay, this one is long. Okay, so these two are lost. So I'm trying to change the sync actually. Okay, this is basically our source and target. Now we have to change the target here. Okay, so what we have to do, data source is this. Create transaction S3, table name is this. Let me check. Here also 28 lines. 87. Okay. Okay, fine. So now apply mapping. So we just selected these columns. So in mappings, like we are basically mapping, this is the mapping what we are doing, like what is the actual column names, and in the program what are the column names used. So I'm not touching it, so it remains as it is. But here in the selected fields, I have to select only these two columns. That is account number and category, the account number and amount, because I want to find out the sum of transactions for every account number. I'll be doing, I'll be selecting only these two columns. Rest of the columns I will remove. Okay, so that is there, and then I'll be applying some aggregations here. Okay, so what I'll be doing, say aggdf is equal to, then selected fields. This is the dynamic frame dot to df dot group by acc num dot ag. Inside that I'll be calling the function that is sum of column of amount, right? Dot alias. What is the table name, column name, what I've given there? Amount only, right? And amount only. Okay, this is how we just did the, we took that dynamic frame, converted to data frame dot group by account number dot tag sum of amount dot alias amount. This is what I did. Then okay, then I have to import also. Where is your PyCharm? Is it open? Okay. PySpark SQL types. Types. Okay, PySpark context. Okay. Import start. Let's import the functions also. From PySpark to SQL functions. Import start. Okay. Because we are using call function here. Okay, we just created a data frame, but to write it, we have to convert it to dynamic frame only. Then say egg and then ag underscore dynamic frame is equal to so you have to import the dynamic frame. Okay, Spark context, blue context. So we are converting a Spark data frame to a dynamic frame here. So this one. Okay, so active. So what it is doing here. Okay, so you have to keep the same name here also. Control C here also. Okay, this is how you can convert your data frame to dynamic frame. So from AWS Glue dynamic frame, import dynamic frame, then dynamic frame dot from df, our Spark data frame, Glue context, and the dynamic frame name. Okay, everywhere you're seeing all these functions take the variable name as the parameter. Here also apply mapping, you can see it is a variable name, isn't it? Post that, what we are doing, we just created this ag dynamic frame. Okay, ag dynamic frame, but I think select these two must be used somewhere. Okay, resolve choice, apply, select field 2. Select field 2, just choice, map catalog, create transaction, redshift DB, table name, rs type public this, transform. Okay, this we have to carefully change it and just copy pasting as it is. Here basically we are saying which destination this table will go into, so it is no more selected field, rather it's basically ag. Frame name is agdf. Agdf will go. Database name is create transaction rs underscore ag underscore. Okay, let's shift agdb. No, I don't think so. I think transaction ag underscore redshift db. Then table name is rs take public create transaction ag. Transform is this. Let me quickly verify what are the table name I've given there. Create transaction ag rs. Create transaction ag rs is the crawler name. If I'll go into this connections, okay, database name is create transaction ag rsdb. Create transaction ag rsdb. Where is the database name? Create transaction ag rsdb. This is the database name and the table name. Table name I've given rs underscore. Okay, I've given dev public create transaction ag. So rs underscore dev public create transaction ag. rs underscore dev public create transaction ag. And that's it only. Then we can delete this. And now I think we are pretty straightforward. We're writing this data result choice apply, dynamic frame choice, make columns, context this, data sync. You're saying glue context at right dynamic frame from catalog, resolver this, database name is create transaction rsdb. No, create transaction ag rsdb. Okay, the database name is create transaction ag rsdb. Here I just changed it. Table name is rs take public create transaction ag temp directory and all this. I think, and this is what. And just Control A, Control C, and we go to the job section. Now I'll be modifying this code. Control A, Control V. Okay, save, run job. It will take a while. Let's see. You would have like put a show statement. Anyway, let's see. It will take a while. So what we did here, we just tried to reutilize the same code what we prepared to read data from S3 and write it to Redshift. I just took the same code because I'm not well versed with the APIs. So I took the same code and I made some tweak there. And most of the code are same, only the data transformation part is different. You created a dynamic frame and you're writing a dynamic frame to Redshift, that is same, only the middle part. So on top of that data frame, it's a dynamic frame. I convert it to data frame, Spark data frame, and then apply some test data frame is not defined. Okay, got it, some error. I got it. Let me see where this test df. Test data frame is not there. It's actually ag df. It's actually ag df. Save, run job. Okay, so these are so I just used the previous code as it is and made some changes. That is converting the dynamic frame to data frame, then apply some aggregations, group by account number, add sum of amount, and I give it alias name that is also same. And then I converted that Spark data frame to dynamic frame. Data frame object has no attribute resolve choice. Okay. Where is that resolve choice? Okay. It's not AggDF, it is Agg dynamic data frame. Dynamic frame. Okay. At least they've improvised this system. Earlier it was very lengthy. Every time you run it, you have to wait for at least 5 minutes. Now it's very fast. Because yeah, they are also trying to improvise their system. You got my point, right? Means we just read the data and we applied some aggregations on that, converted that Spark data from back to dynamic frame, and now we are writing it to Redshift. That's the whole program is all about.
We achieved using EMR.
Exactly. So all whatever things we are doing, everything we can achieve through normal Spark. Here only the development is faster. That's correct. The development is much faster. You don't have to create a application in PyCharm and do all these things. I think it completed, right? Let's quickly see. Yeah, you are correct. So the development is much faster here, like when you're using this AWS Glue. You saw like just in a text area, you were writing the code and a lot of drag drop. You can create crawlers there on the fly. Okay, so development is much faster. So you can only focus on the business logic, write the code here. Rest of the dev part, infra part, everything is handled there seamlessly. Okay, you can see this is the sum of transaction per customer ID. Okay, so that is there. So that's all about your Glue part. Okay, you can anyway like take it further, work on multiple other tricky use cases. Okay, so you can do that for sure, but yeah, so you got the point, right? We tried two use cases. One is a normal data ingestion problem. Read data from Amazon S3 bucket to and just write it to Redshift. And the project part also will be doing similar thing, but using Spark application. But here we are doing it through AWS Glue. Then we saw one example how to apply some aggregations and write it to Redshift. Okay, and it's not just limited to S3 and Redshift. You saw you can read pretty much any sources, any RDBMS, S3, MongoDB, DynamoDB. Okay, any databases, RDS, hosted over RDS. Similarly, sync can also be anything, right? So all these functionalities are there, and we can basically it's basically many companies are using this as one of the like in development infrastructure for Spark application. people, companies, as I mentioned, like startups and all, who have lesser fund for this. So for like data engineering activity, they are preferring AWS Glue. Okay, so you can see development is much faster. You can write all your business logic here in one notepad in this particular text area, and you can start executing it. Okay, so everything is working fine, right? So any queries on this? Anybody?
Yeah. Do we have to delete these crawlers or something, or let it run as it is?
No, it will not run because we have given on-demand run. So you will not get charged after this. Okay, we have not given an automated run.
Okay. So for automation, we will use all those step function and other things. How these things will be automated?
Yeah, just like you saw, you created a AWS Lambda to create a cluster and run the job. Same thing also you can do. You can basically create a Lambda script, and from Lambda script you can invoke this workflow. Okay, all these things you can do there. Okay. And you can automate to run it on a given time frame also. Okay, at this particular time, just let's run this workflow. That also you can do. Okay. Any other queries, Ankun?
No.
Vinay?
No, Siddharth.
Okay, then just give it a practice. Okay, so trust me, like if you just add all these kind of like, these are very new things. Okay, so if you show that, for sure you'll be getting like your resume will stand out, like because you're adding all this latest stuff. So it's not very new. Last 2 years people are using, but yeah, things are getting improvised. Like now you can see things are happening very fast. Earlier, like to run it once, it will take 5-10 minutes. Now I can see a lot of development happen. So these are the things, like if you show, you'll get a lot of your resume will look good actually.